All right, let's talk about some of the real unsung heroes of the industrial world, compressors. These things are unbelievably powerful, but man, you have got to respect them. We're going to find out exactly why. The whole story of a compressor really boils down to just one thing: immense energy. These are not your average pumps. They are high stakes, high energy containment systems. And getting your head around that fact is the absolute first step to working with them safely.
So, what's their job really? Well, in a nutshell, a compressor takes a gas, squeezes the heck out of it into a smaller space to ramp up its pressure, and then uses that super energized state to power all kinds of industrial processes. Seriously, it's the engine behind so much of what we make.
But you know what they say, with great power comes great risk. We're talking about machinery that combines incredible speeds, extreme pressures, and soaring temperatures all in one place. The potential for a major incident is always there, which is why safe operation isn't just a good idea, it's absolutely non-negotiable. So here's our game plan. We'll start with that balance of power and peril. Then we'll take a look under the hood at the different types, cover their essential life support systems, walk through the operator's playbook, and finally get you prepped for a code red situation. Okay, so let's be real clear about this. Managing all that power and dodging the peril, it really comes down to one thing, and that's the knowledge and the vigilance of the operator. Your understanding is the number one safety system. All right, let's pop the hood and see what we're working with. Because, not all compressors are built the same. They're highly specialized tools, and the right one is always picked for a very specific job, depending on what the process needs. At the top level, they basically fall into two big families. On one side, you've got your dynamic compressors. Think of a centrifugal type. These things use pure speed, spinning these parts called impellers to literally sling gas outwards and build up pressure. Then, on the other side, you have positive displacement compressors, which physically trap a chunk of gas and then squeeze it. The best example? A piston moving inside a cylinder. Now, this is where it gets really interesting, because this chart tells you the why behind each type. If you need to move a massive amount of gas, but the pressure doesn't need to be crazy high, the centrifugal compressor is your workhorse. But what if you need to hit some extremely high pressures? Even if you're not moving a ton of gas, well, that's a job for a reciprocating compressor. And for those times you need a nice, smooth, continuous flow, you'd go with a screw compressor. See? The process always picks the machine. But here's the thing, it doesn't matter what kind of compressor you have, none of them can do their job alone. A compressor might be the star of the show, but it's not a solo act. It relies on a whole network of other systems to keep it running safely. Just think of them as the machine's own dedicated life support team. And these are the big ones, the absolute non-negotiables. You've got the driver, that's the muscle, usually a big electric motor or turbine. The lube oil system is the literal lifeblood, keeping all the moving parts from grinding themselves to dust. The seal system is crucial. It keeps that high-pressure gas from escaping. And of course, the cooling system, which has the massive job of managing all the heat. If just one of these fails, the whole operation is at risk. For all the complex systems working to keep it safe from the outside, the single greatest danger to a dynamic compressor actually comes from within. So what do you think it is? What is its greatest enemy? The answer is a condition called surge. And trust me, it is every bit as terrifying as it sounds. It's this incredibly violent event where the gas flow inside the machine actually reverses on itself for a split second. This causes these massive vibrations and pressure waves that can literally tear the machine apart from the inside out. And that is why the anti-surge system is one of the most critical pieces of safety equipment you'll find on a centrifugal compressor. Which brings us to the most important piece of the whole puzzle: you. The operator's every move is guided by a strict set of procedures. A playbook, really, that's designed to guarantee safety from the second that machine starts to the moment it stops. Yeah, starting one of these isn't like turning the key in your car. It's a precise, careful sequence. First, you have to confirm that all of its life support systems are up and running. Then, you follow a strict step-by-step procedure from the control room, while the operators in the field are your eyes and ears on the ground, listening and watching for any tiny sign of trouble. The source material is clear on this. Skipping steps leads to failure. Period. So once it's up and humming along, your job becomes all about vigilance. You are the guardian of what's called the safe operating envelope. That means you're constantly watching the key numbers: flow, pressure, temperature. You're looking at trends, trying to spot subtle changes that could be an early warning, and you report anything that looks or sounds out of the ordinary right away. Pushing a machine past its design limits is just never, ever an option. And don't forget, bringing the machine down for a stop needs just as much care and attention as starting it up. A messy, chaotic shutdown can cause serious damage and send shockwaves through the rest of the plant. A planned, controlled shutdown is always the goal. But what happens when things start to go sideways, even when you're doing everything right? Well, that's when we enter code red territory. And understanding alarms and trips is absolutely critical. This chart tells a really clear story about what you should be watching for. High vibration is the #1 red flag, a whopping 40% of the time. Right behind that is high temperature, and then problems with lube oil pressure. You add those three up, and that's 90% of the common alarms you're ever going to see. Now, the whole protection system is designed in layers. First comes the alarm. Think of that as a tap on the shoulder, an early warning telling you to pay attention. That's your cue to take action, investigate what's going on, and fix it. But if the situation doesn't get better and actually gets worse, the system itself steps in with a trip. That's an automatic shutdown, and its only job is to save the machine from destroying itself. And this right here, this is the golden rule. A trip is not some annoying obstacle getting in your way. It is a safety device doing its job. It is the last line of automated defense for that machine. Bypassing a trip is like disabling the airbags in your car right before you get into an accident. You just don't do it. Ever. So when you think about it, after all the incredible engineering, all the automated systems, all the procedures, when a real crisis is unfolding, what is the true final line of defense? It's you, the trained, the knowledgeable, and the responsible operator. An automated system can protect the machine, sure, but a calm, well-trained operator protects everything. Because at the end of the day, no matter what the pressure is to keep things running, safety always, always comes first.